Hi, I'm Paul. This is Science That Sticks. Let's look at mixtures. Roll the graphic. Mixtures and how to separate them. This is pretty easy stuff, and it's revisited in year 11 in a module called C8, which is chemical analysis. But today we're just going to look at some basic terminology and how to separate mixtures. So some of the basic terminology would be solute, solvent, solution, insoluble, and solvent. Although I think I've mentioned that twice. Either way, doesn't matter. So what do those things mean? Well, if you've got a solvent, that's a liquid that you are going to dissolve a soluble solute into. Salt, for example, is a soluble solute. Solute just simply means the solid. Now, sand won't dissolve, so it's insoluble, and it is a solid. So sand is an insoluble solute. It will not dissolve. Basic stuff. When we dissolve a soluble solute into a solvent, the resulting mixture is a solution. Easy. What if we've got a solution already, like seawater, and we want the crystals, or we want the seawater? Well, we can use either crystallization or evaporation or distillation. Let's go to the board and let's have a look at both of those two techniques. Okay, so let's say that you live near the ocean, there's not much fresh water around, and you want that pure water from the ocean. Well, the best way to do that is distill it. Distillation exploits the fact that water happens to have a lower boiling point than the salt's melting point. So you heat it up, the water evaporates. As the water evaporates, instead of it being released into the atmosphere, it's captured and drawn through a condenser. Cold water goes in here, it cools the condenser, and the water leaves. Now this is a jacket around the outside of it. There's a pipe that goes through it, and then there's like a water jacket that's enclosed in glass. Now this is not very difficult to understand or imagine. You can download pictures of them and what have you, and your teacher will show you anyhow. So that's what happens here. The steam condenses. As it condenses, it turns back into a liquid, and you end up with pure water, the distillate. It's also much cleaner to drink because you've already heated it over 100 degrees Celsius, which means you've got rid of any bacteria or pathogens. But let's say though that you don't want to be faffing around with all that heat and losing that energy and so on. The best thing that you could do with it is perhaps get the salt and sell it. And that being the case, you're going to need crystallization or evaporation. So you allow your salt water to evaporate. The water evaporates, leaving behind the salt. The salt gets crystallized. You come along and you dig it up. Now we're talking industry here. In the science lab, you're going to look at a much smaller scale. So you've got your salt water. You put it into a evaporating basin. You heat it up. The water evaporates at 100 degrees Celsius. The salt that is left behind hasn't even melted at that point. So you end up with the salt crystals, and you end up with nice big salt crystals if you do it right. We call this evaporation, and you end up with the pure crystals. So, mixtures. How do we separate salt from water? Distillation or evaporation. Let's say for a moment that you've got a mixture of ethanol and water, perhaps in some sort of drink, or maybe you've just been unlucky and you've just been awarded this weird mixture. Now ethanol boils at around 74-75 degrees Celsius, not quite 100 degrees, which means it will evaporate first when heated because it's got a lower boiling point. As you continue to heat it up to 100 degrees, then the water boils. So what you do is you distill this if you want the ethanol. So you heat it up. The ethanol gets to 74, 75, I think it's even 77 or 78, who cares? But either way, it's a lower boiling point than the water. That evaporates. You take a measurement on the thermometer. That tells you what the temperature is. As soon as it reaches the boiling point of the ethanol, that is what will condense. As it condenses, your distillate will be pure ethanol. Dead easy. This is true if you've got several liquids that have different boiling points. You could use the same process. Now, the ink in most pens is not just one one component. There's often lots of components to it. The solutes are soluble in that solvent that is present within the pen ink. And because they all mix together, this is a bit of art. So they all end up making the black ink. But if you want to find out which pigments make up this black ink, maybe you're a Scenes of Crimes officer and you want to find out who done it by identifying the pen. So what you would do is you would use chromatography. In chromatography, you have a beaker, you have a lid, you have a solvent. This is quite often water in schools. Sometimes you might use acetone or maybe even ethanol. And you've got your chromatography paper. It's not very well drawn, but it's a sketch, which is drawn approximately. The origin's drawn in pencil. You've got your samples. As the chromatography paper absorbs the fluid, it will dissolve your samples, assuming that they are soluble. As the water passes up and is absorbed, the small particles or the most soluble particles will readily dissolve and they will be carried up with the absorption, and they're dropped off at different heights. You then measure the height against what's known as their retention factor. We'll discuss that another time, but that's how chromatography works, separating out all the different solutes. There's one last one, filtering. How do we filter? So what's the last of these bad boys that we need to know about? We need to know about filtration. Filtration is the physical separation of an insoluble solute that is in your liquidy mixture. The best example that teachers give is a sand salt water solution. And I always do this. And so what we do is we make our own sand salt mixture. We get a beaker, we stir it, and we really stir it so that all the salt is dissolved in the water. We then pour it through filter paper, which is in a funnel, and we have a beaker to collect it. The filter paper physically stops the larger sand particles or the sand grains. They are too big to go through the paper. The water passes through because water's small molecules, and the ions that are dissolved from the salt are also tiny, so they go through too. What's left over in here we call the residue. What has been filtered is called the filtrate. So that's it. What have we learned? Well, we've learned that mixtures can be elements and compounds that are next to one another. They can be different elements that are next to one another, like nitrogen and oxygen in air. We've also learned that these are physical processes that can only be separated by physical means. And there's several different ways that we could do this. We can use distillation, we can use evaporation, we can use chromatography, and we can use filtration. And until next time, ladies and gentlemen, as always, stay cool and take care. Bye for now.